Okay, think about this for a second. Every single day, something like over 100,000 planes are taking off and landing all around the globe.
It really is an astonishing number when you pause to consider it.
Hmm.
Huge machines just
Yeah,
up there.
exactly. And it just begs the question, how on earth does a massive piece of metal actually stay airborne?
Right. It seems almost counterintuitive.
So that's what we're diving into today. We're looking at our source material, how airplanes operate, trying to unpack the science behind it all.
The goal really is to move past seeing it as just, well, magic and understand the engineering.
Absolutely. And it turns out flight really boils down to these four fundamental forces. Get these, and the whole thing starts to click.
It does. It provides a framework for understanding.
So first up, we've got lift. That's the upward force, obviously. It mostly comes from the wings.
Uh-huh. And specifically, it's about their shape. That sort of curved top, flatter bottom, the airfoil.
Right, the airfoil. And the key thing is how the air flows over that shape. It goes faster over the curved top surface compared to the bottom.
Exactly. And that speed difference is what creates a difference in pressure. Faster air means lower pressure on top.
Lower pressure on top, so it's almost like the higher pressure below is pushing it up, or the lower pressure is sucking it up.
Both ways of thinking about it work, essentially.
Yeah.
It's Bernoulli's principle in action. That pressure difference generates the upward lift force. It's the core idea.
Okay, makes sense. Now, fighting against lift, you've always got weight.
Always. Gravity pulling everything down towards the Earth, the plane's entire mass.
So lift has to be stronger than weight for the plane to climb, or at least equal to stay level.
Precisely. Then you need to move forward. That's where thrust comes in.
Generated by the engines, right? Jet engines or propellers.
Correct. They work by throwing air, or rather, hot gas, backwards at high speed.
Ah, like Newton's third law.
For every action, there's an equal and opposite reaction.
Yes,
Exactly. The action is pushing the gas backward. The reaction is the engine, and thus the plane, being pushed forward.
Simple concept, but incredibly powerful when you scale it up like that.
Definitely. But as soon as you start moving forward through the air,
You hit resistance.
you hit resistance.
Yeah.
That's drag. It's the force of the air pushing back against the plane, trying to slow it down.
Like sticking your hand out of a moving car window. That feels...
That's a perfect analogy. That force you feel pushing your hand back, that's drag. It directly opposes thrust.
So for takeoff then,
Yeah.
you need the engines to create enough thrust to beat the drag, and you need the wings moving fast enough to generate enough lift to beat the weight.
That's the moment.
Yeah.
When those conditions are met, lift overcomes weight,
Yeah.
thrust overcomes drag, and the plane leaves the ground. It's a balancing act.
And once it's flying, how do pilots actually steer this thing? It's not like a car.
No, not quite. They use specific control surfaces. To roll the plane tilt the wings side to side, they use ailerons. They're on the outer edges of the wings.
Okay, so tilting one wing up and the other down, basically, for turn.
Exactly. Then, to pitch the nose up or down, they use the elevators on the horizontal part of the tail.
Elevators. Makes sense. Up and down.
And finally, to yaw the nose left to right, sort of like shaking your head no, they use the rudder on the vertical tail fin.
Ailerons, elevators, rudder, controlling roll, pitch, and yaw.
That's the trifecta. All managed from the cockpit, of course.
And I imagine there's a lot of computer assistance nowadays, too. It seems incredibly complex to manage constantly.
Oh, absolutely. Modern cockpits have sophisticated flight computers making constant tiny adjustments. But the pilot is still crucial. And let's not forget air traffic control coordinating everything on the ground.
Right. It's this whole system working together. The physics, the engineering, the human skill.
It really is. When you break it down, defying gravity like this every day isn't magic at all. It's just, incredibly clever science and engineering applied brilliantly.
Yeah, it shifts your perspective from just seeing a plane in the sky to appreciating the intricate dance of forces making it possible.
Which kind of makes you wonder, doesn't it? If understanding the science behind something we see all the time like flying makes it this much more fascinating.
No.
What other everyday things are out there? Things that seem mundane, but if you dig into how they actually work, you find these, equally amazing feats of science or engineering hiding in plain sight.
That's a great thought to leave